Hi, this is from Dr.B. Vijayakumar, HOD of Physics, SNS College of Engineering, Coimbatore. The another one topic we discussed in Young's modulus uniform bending theory and experiments. This also is a form of properties of matter. So the brainstorming session, the question will be raised in the student side. It's one is in a define Young's modulus and difference between uniform and non-uniform bending. The introduction part of the Young's modulus, the ratio between the longitudinal stress to the longitudinal strain within the elastic limit. So the Young's modulus Y equal to longitudinal stress by longitudinal strain. Let us start from the uniform bending theory. Consider a beam supported by two knife edges A and B. Length between A and B is L. Let equal weight W be added to either end of the beam C and D. Let the distance CA and BD equal to A. Due to the load applied, the elevation into produced from F to E. Let W be the reaction produced at the point A and B which act vertically upwards. From the figure, the external bending moment about P written as MP equal to WA. The internal bending moment equal to Yig by R. So at the equilibrium condition, the internal bending moment is equal to external bending moment. Therefore, the WA equal to Yig divided by R. Here it's found the elevation into form of arc of the circle of the radius R. So this is the circle to form in the bending moment at the exact middle of the beam. So the triangle AFO, the OA squared equal to AF squared plus FO squared based on the Pythagoras theorem. The OF is equal to EF. OA squared equal to AF squared plus FE squared, or AF squared is equal to OA squared minus FE squared. So the AF squared equal to FE, OA squared by FE minus FE. AF we know that L by 2 and FE equal to X equal to R by 2. So the OA equal to R. So the L by 2 to the whole square equal to, we get the X R squared by R by 2 minus X. The L squared by 4 is equal to the simplified form of 2XR minus X squared. The elevation X is small. So the L squared by 4 equal to 2X capital R. The capital R we consider the radius of curvature. So the X equal to L squared divided by 8R, or R equal to L squared by 8X, or WA equal to Yig divided by L squared by 8X, or WA equal to 8YIGX divided by L square. Now rearranging, the elevation of point E above A is X equal to WA L square divided by 8YIG. Then we start a experimental verification. This is a diagram, block diagram of Young's modulus uniform bending. So the both side we add a weight that we call as a mg, and distance between two knife edges is called L, and distance between one weight anchor and the nearby the knife edge is a A. So this is all to given from clear procedure formation. The given beam of length AB is symmetrically placed over the knife edge. The two weight hanger are suspended, one each on either side of the knife edge at the equal distance from the knife edge. A pin is fixed vertically exactly at the center of the beam, that is equal to the C using some wax. A traveling microscope is focused on the tip of the pin. The beam is brought to the elastic mode by periodical loading and unloading of the weight on both sides, weight hanger simultaneously. The reading in the vertical scale of the microscope is noted. Weights are added in an equal step of m/kg on both the weight hangers, and the corresponding reading are noted. The readings are noted while unloading also. The length of the beam, the weight hanger, and any one of the adjusted knife edge D, breadth B, and thickness D of the beam are measured with a vernier caliper and screw gauge respectively. Hence, the Young's modulus of the material of the beam can be calculated. Young's modulus of the material of the beam E equal to 3mgAl square divided by 2bd cube by Newton per meter square. So finally we get the experimental method wise the Young's modulus of the material of the beam we have calculated. By using this tabulation, we find out that observed reading from the bar. The first one is in a breadth to finding for using in a vernier, and second thickness to finding in a screw gauge for using in a screw gauge, and third one is in a the bending moment, that is a depression. So this is all the reference. I prepared the PPT to discuss in Young's modulus, uniform bending theory and experimental. Thank you very much. We discussed in another one video of the problem sum matter.